Ever wondered if reality is fixed, or if it only decides what it is when someone's looking? Back in the 1930s, this wasn't just a later night thought, it was the biggest problem in physics. Quantum mechanics, the most successful theory ever, seemed to suggest something truly bizarre, that an object could be in two opposite states at the same time. This wasn't just a quirky idea, it was a prediction that one day this weirdness could be harnessed into real-life quantum cats, quantum computers, and sensors that would totally rewrite engineering. The story begins in 1935. Europe was on the brink of war, but physicists were fighting their own battle over the meaning of quantum mechanics. The theory worked perfectly for describing atoms, but its rules felt deeply unsettling. The dominant idea, called the Copenhagen Interpretation, said that tiny particles don't have definite properties like a specific location until you measure them. Instead, they exist in a superposition of all possibilities at once. Erwin Schrödinger, who had actually won a Nobel Prize for helping build this theory, started to have serious doubts. Schrödinger wasn't some outsider. His wave equation was a cornerstone of quantum physics. But he couldn't stomach the philosophical leap his colleagues were making. The idea that a particle only picks a state because an observer looks at it seemed absurd. In a series of letters, many with Albert Einstein, he decided to push this logic to its breaking point. If quantum rules apply to atoms, he argued they should apply to big things too, right? To show how strange this was, he came up with an infamous thought experiment. Imagine a sealed steel box. Inside there's a cat, a tiny bit of radioactive material, a Geiger counter, and a vial of poison. If the Geiger counter detects a single atom decaying, it triggers a hammer that smashes the poison, and the cat dies. This setup was never actually built. It was a mental puzzle designed to show a flaw in the logic. Here's how the quantum trigger works. The radioactive material has a 50/50th chance of decaying in 1 hour, according to quantum mechanics. Before you check, the atom isn't just decayed or undecayed in a superposition of both states simultaneously. Since the cat's fate is directly linked to that atom, the entire system becomes entangled. So, if the atom is both decayed and not decayed, then logically the cat must be both dead and alive until someone opens the box. Now, Schrödinger's real point wasn't that cats can be zombie ghosts. He thought this conclusion was quite ridiculous. He wanted to show that if you take the quantum math literally as a complete description of reality, you end up with nonsense. In the Copenhagen view, the cat exists in a superposition of alive and dead until an observer opens the box, causing the system to collapse into one definite state. This clashes with our everyday experience, where a cat is either alive or dead, regardless of whether we're looking. So, contrary to popular belief, the experiment didn't prove that quantum magic is real. It was a criticism, not an experiment. Modern physics has a better explanation called decoherence. It suggests that interactions with the environment, the air molecules, the Geiger counter itself, would force the system into a definite state almost instantly, long before a human ever peeked inside. No conscious observer needed. But here's the amazing twist. Decades later, scientists started creating real life, microscopic Schrödinger's cats, not with actual animals, but with things like superconducting circuits or vibrating membranes. They've successfully put these systems into a superposition of two distinct states at once, like having a current flow both clockwise and counterclockwise simultaneously. These experiments are helping us find the boundary between the quantum and classical worlds. The paradox also fueled a war of interpretations. Some say the math is just a tool for predictions, not a picture of reality. Others, like the many worlds interpretation, suggest that every possibility happens in a separate, branching universe. So in one universe, the cat is alive, and in another, it's dead. The wave function never collapses. And the boldest prediction of all, the very quantum weirdness that bothered Schrödinger, is now the foundation of a technological revolution. Quantum computers use qubits that are in superpositions of 0 and 1, like the cat being alive and dead, to perform powerful calculations. So, the story of Schrödinger's cat isn't really about a cat at all. It's about physicists wrestling with the profound meaning of their own discoveries. It was a thought experiment that evolved from a philosophical puzzle into a roadmap for the future, guiding us as we build technologies that harness the very strangeness that once seemed so absurd. Thanks for watching, and don't forget to subscribe for more deep dives into science.